Breaking the wall of the unshakable virus. Mahlaqua Noor, University of Cambridge.
I've got good news and I've got bad news. Bad news is more than half of the people sitting in this room are infected with a virus they've never even heard about. We're going to change that today. Good news is you've got nothing to worry about as long as you stay healthy. I'm talking about the human cytomegalovirus, a virus with significant global burden of disease affecting more than 80% of the global population. Once the virus enters the human host, it finds its way in the bone marrow, where it will stay for life. In a healthy adult, the immune system is robust, and it will make sure that the virus stays in check. However, in an immunocompromised setting, such as in a cancer patient or a transplant recipient, the virus can reactivate from the bone marrow, enter the bloodstream, cause major inflammation, and often massive complications. Unfortunately, there is no vaccine on the market, and the antiviral drugs that are administered can be toxic and ineffective because of viral resistance. So how do we go about treating patients who are extremely sick with cytomegalovirus? Our answer is immunotherapy, whereby we harness the power of the immune system to treat immunological diseases. I'm particularly interested in natural killer cells. They are cells of the immune system that are licensed to kill. On their cell surface, they express killer receptors, and these killer receptors can recognize viral-infected cells and kill them. I'm looking at the natural killer cells of human donors that are infected with cytomegalovirus, and I'm trying to understand what killer receptors on the surface of these natural killer cells make the killer cells better at killing. And I'm doing so by looking at big data clustering models as well as sequencing. Once these killer receptors are identified, they can be expressed at a higher proportion on the surface of natural killer cells. And these killer cells are now called CAR-NK cells. These CAR-NK cells have a much higher therapeutic potential than your normal NK cells, and they can recognize the virus at a much faster rate. They are then transfused into the patient's body, whereby they'll find the virus and get rid of it. CAR-NK cells not only have a much higher therapeutic potential, but they're also safe, as well as they can be stored long-term. Therefore, they are readily available for use. And they can be given to patients who are extremely sick, thereby maximizing their survival rate, as well as improving their quality of life.
Questions?
Have these therapies been tried before? And as you know, CAR T cells are very expensive. So how do you plan to do this overseas, in many countries?
So our primary data is mostly focusing on looking at clinical trials that are focused on cancer patients in more Western countries. But the good thing about NK cells is that there is less chance of toxicity, which is a huge bonus compared to the CAR T cells.
I mean, they do have to be very specific to the CMV you're trying to treat. You haven't explained how you tailor that.
So that's why I'm looking at the natural killer cells of patients who are infected with cytomegalovirus, as opposed to any other donor. I'm trying to look at how they can control the virus better. So that's why I'm identifying killer receptors found in cytomegalovirus patients.